Good morning, students. In today's class, we will discuss about the concept of structures. So, module 4 in your computer programming course is about functions, structures, and union. In the previous classes and the videos shared related to the concept, we have discussed about functions, right? So wherein we have a specific task which is defined as a function, then it is a separate module. It has to be called and we can pass parameters, and we have seen concepts like different categories of functions and programs in each of the category. And then we have passed array as a parameter to a function also. The next topic is structures. Now, structures is also modular programming. As I told you, module 4 is all about modular programming. So we saw the concept in functions. So modular programming means the program is broken into pieces, right? Different modules. So each one can become one task. If we take, for example, a calculator. So we just saw discuss like add can be one module or one function, subtract another function, and so on. We may write different functions and call them one by one in main. So there we have different modules. And similarly in structures as well as union, which is the next topic, so there also we have modular programming. So before we go into detail about what is structure or how to use it, what is the syntax, etc., let us first revisit one concept which you are all very familiar with, that is arrays. Right? So I hope the white screen is visible, right? Yeah. What is an array? Anyone? What is an array? Rachana?
Yes, ma'am.
What is an array? Am I audible to all of you? Yes or no? Okay, so we have a reply in the chat box. Yes, continuous memory locations are there, collection of elements in order, and each of them are stored in continuous memory location. Okay, index starts from 0. And one more thing, yes, you have missed one more thing. Are they of same type or different type? Each of the element. Same data type. So when it is same data type, what is it called? So all the elements are same data type. That's right. So if they are same data type, so this array is called as a homogeneous, right? Yes or no? Homogeneous collection of data elements, right? Now, what is the meaning of homogeneous? So homogeneous means all the elements of the array are of the same data type, right? So here homogeneous collection of data elements means all the elements of an array are of the same data type. Like if we declare int a of 10, that means this array has 10 elements and each of them is an integer. right? So we cannot store one integer, one float, one character, one double, and so on, right? So in this case, one string. So that is not possible to store in an array. So now assume we have to store a record, like say university wants to store a student details, right? So student details, are they all of the same data type? So we may have to store what are the student details. Say we want the student name, okay, and then we want to store, say, the student roll number, right? So roll number, and say next we want to store mobile number, okay, and then say address, right? So now if you see this, so name is nothing but a string, right? We want to store name of the student, each student, and roll number is say alphanumeric, right? Both numbers as well as alphabet. Mobile number is integer. Address is again a string. So if we see this, all are of the different data type. Now, if I say I will take one string of names and store all the student names, and then another I will take only another string to store all roll numbers, then I'll take different integers and store mobile numbers, and another string to store all addresses. Is it feasible? Now then we have to search it separately, right? It is not possible for us to extract one student details from all the collection of elements. Now to make this possible, we have the idea of structures. So it is opposite of homogeneous. What is opposite of homogeneous? Homo is same. So in that case, opposite is
Hetero.
hetero. Very good. So here
Heterogeneous.
structure is heterogeneous data structure. That means each of the element may be of a different data type. Note that. So structure, right? So structure we have. So in that case, it is heterogeneous. Right? So heterogeneous elements are there. So in this case, structure is heterogeneous. We can store one name, okay, of the student. It is string, roll number. So it may be integer or alphanumeric. Again, it can be stored as string. Mobile number is integer. Then address, a string. Say we want to store some average marks, so that becomes float, right? So then so on, we can store many different details, right? Average marks will be 0.5 or so on, so it becomes float like this. So we can store any detail. So each of them are a different data type. So here we may have a character array, so that is nothing but a string. So here again we may have depends. So in this case, our roll numbers are all alphanumeric, so it is a string, and mobile number is integer. Address can be a string, right? And average marks will be of the data type float. So similarly, you may have any example wherein the details are all of different data type. So if we want to store one student's details, the details are of different data types. We cannot declare like student one array and store all of them in that array, because array is homogeneous. All these are different data types, so we cannot store heterogeneous data into array. If we store each of them in a different array, then it becomes difficult to extract one student details, right? We may store one name, right? Names of all students in one array, then roll numbers of all students in another array. So if we store like that, it is difficult to extract each student details separately. So what do we do? So we can store these details only, so related details. Note that it is not any random data. So we are storing only related to that particular student, okay? So here we will not store some random data, but otherwise we will store related data which is of different data type. So all of these are different data types, but they are related to one student, right? So one student's name and the same student's roll number and his mobile number, his address, his marks are stored together. So it becomes easy to extract the required data, right? So let us see, how do we define this? I will just display one, just a minute. Is this screen visible? Structures? Yes.
Yes, ma'am.
Yes, okay. So let us see what is this structure, right? So here we have different elements, right, of different data type, but they are logically related. Like we saw, they are all related to one student: name, roll number, address, mobile number, etc. All are details of one particular student, so they are related items. We can store them together, right? So for this we have to declare one structure. Note the syntax. So here we can see how to declare a structure first. So this has, the first word is the keyword struct. So if it is a keyword, it has to be written in small letters. Do not write capital S. Okay, that is one common mistake observed. So struct is a keyword. All the letters have to be written in small letters. And space, we have a tag name. We may give like student. In this example, we want to store details of one student or many students. Okay, each of them is details of a student. So we can give struct space student, and within brackets curly braces. Note this. So we have each of these are members. So if we say student detail, name is a member, roll number is a member, mobile number is a member of the structure, address is a member of the structure, and average marks is a member of the structure, right? So we have to declare each member like we declare any variable in main. In structure also we have to declare the members. So here we may declare, say if we want name, right, that is a string. String is nothing but a character array. How will we declare the string? Char space name of say 50, right? So any size we can give. So name of 50, that becomes the first data. Then next, now we have the roll number. So that also if we want, we can declare as string or int. So char space roll number of 12, because there are 11 or 10 digits, right? 10 digits plus one null character. So keep in mind, one null character also is required. So we may declare a larger size also, 10 or 15 you may give. So similarly, we can declare each of the members, right? Elements of the structure can be declared. Let us see one example, right? That was student. If we want to store details regarding a book. Now, one more important thing is, after declaring, close the bracket and note there is a semicolon. So semicolon indicates that it is the end of structure declaration. Like we give int a semicolon. So semicolon is end of that statement. Similarly, at the end of structure only. It is not there for functions or any other places. Okay. So loop or anywhere else, only in structures and unions. So we will give a semicolon at the end of the bracket. After bracket there is a semicolon, that is part of the syntax. It indicates that we have completed defining the structure. So here we say that this is a structure and these are the data members. Let us see one example. Say we want to store details of one book, right? So book can have a title, an author, and its price, some ISBN number, and so on, right? There are many details. We will consider we want to store three details of particular book, right? So in this case, we have defined the structure. You can note the example here: struct keyword space book bank. So this is the name of our structure. Within bracket we can give char space title. So title of the book of size 20. So maximum of 19 characters only. Last one will be null, right? Then int space author. Author is the next one, right? So if we have how many authors, so it is int, not name of the author. So book may have two authors, one author, three authors, any number. So we can give that. Or if you want to give say each author name also, you can give char space author, right? Author name, what the members depends on us, whatever data we want we can give here. Then float price of each book. So this is an example of declaring a structure. So each member is declared independently with a name and the data type. So name is title, data type is character, it is a string, right? Character array, or it is a string. So we have declared a structure. Is the syntax clear? Yes or no? Syntax of structure. Andrew? Yes. Okay. Okay. Yes, so this is a string syntax of structure. We will see some many examples here follows this. Okay, so we saw one example, say we want to store details of a book. Similarly, let us see what all is required. We just saw how to declare or define a structure. So variable declaration, like similar to any variables we declare. So all of them may be same data type or different data type. So if we are using different data types, it is uh, uh, like the advantage of using structure. So we can have all the members of different data types. So here we have the keyword struct followed by the tag name of the structure. And then how do we declare the elements? So here we saw that we have defined one structure. This is for a list of all the books. Now this may be like for book one we have a title book, and for book one we have author, book one we have price. Next, for second book 2 for example, it has a title, it has author, it has price. How do we declare this variable? We can declare it normally like how we declare any variables, right? But the first thing, if we want to declare an variable, we write int a comma b comma c, right? So int is the data type, a b c are variables. Similarly, here we want to write book 1, book 2, book 3, those are all variables, but they are not of type int, they are of type structure, right? So here, note how do we write it. So struct space name of the structure which we have given, that is book underscore bank space book 1 comma book 2 comma book 3. We can declare three elements of the structure, right? So for each book we have a title, author, price. So for book 1 we have title, author, price. Similarly, book 2 has a title, author, price. Book 3 has title, author, price. So we are declaring structure variables. So these are not any simple integer variable or floating point variable. These are structure variables. That means for book 1 there are three parts, three members, book that is title, author, and price. Similarly, book 2 has three parts, right? Book 2 title, book 2 author, book 2 price. Then book 3 has three members, that is book 3 title, that is each book has its own title. Then book 3 author, who is the author of this third book. Similarly, book 3 price, what is the price of this third book? Okay, so we are declaring the variables. So instead of giving only int and variable name, that is how we used to declare simple variables. Here book 1, book 2, book 3 are all structure variables. So for each of them there are three members, so we have to declare them using the name of the structure. Okay, struct space name of the structure is book bank space book 1 comma book 2 comma book 3. This is declaring structure variables. Okay, and then terminate with a semicolon, right? So here we have one example of this book. Next, say we want to store, similarly, we have one other example as well. We want to store our own some personal data, right? Each person wants to store his name. Okay, so let us say we give like this. So we are declaring one structure. Personal is the name of the structure, and inside that we may give any number of members, any number and any data type. So here we want to give a name. So name of the person declared as a string, and the day. Okay, so which day he was born. So date of birth and salary we want to store for different people. So this is another example where we want to store the name, date of birth and salary of different people. Now we know that it is all of different data type. So date can be 1, 2, 3 up to 31 max, right? So that is an integer. Month, January, February and so on up to December, that is a month. And year which he was born, he or she was born, that is an integer. And then we also want to store salary of that person. Salary may be float. So we have defined that as a structure. Okay, structure personal. So name, date of birth, that is date, month and year, and salary we want to store for each person, and give a semicolon. Okay, now this is defining the structure. Now how will we declare a element of this structure? Now we want to access this element, right? We want to store the name of the person. How to do this? Note to the right hand side, we have the first statement. Carefully analyze this. Struct personal space person. Struct is the keyword, personal is the name of the structure space person is a name of variable. This is a structure variable. Now we have person is one person, right? He has a name, he has a date of birth, right? Date, month and year, and he has some salary. We want to take input first, right? How do we take input? For this, we will use a dot operator. Note this. So when you see here, person is the name of the structure variable. This person has a name. He has a date in which he was born. He has the month in which he was born, year in which he was born, and the salary of that person. Now to access this, we are going to use a dot operator. Note, very important. How to access the name, right? So name is the first member in the structure. So we have structure variable name person. We will use a dot operator. To access the name, we will give person dot name. Yes, do you see here? So because this is a string, we do not give ampersand. For strings, we can simply give the name. Like if we declare char s of 10, we can simply take input by mentioning scanf percentage s comma s. That's it, right? Only the name of the string is enough. So similarly here, name of the string is name, but it is a member of a structure. So to access this, we will give person dot name. Similarly, next we have day in which he was born, first, second, third. So that is an integer. So percentage D is the next variable input. So person dot date, right? So how to access the member of a structure? We use a dot operator. So name of the variable person is the name of the structure variable. Dot name of the member. Each of this is a member of the structure. Person is a variable, structure variable. So person dot name will give the name of the person. Person dot day is a day in which he was born. Person dot month, it is a string. So again, no need of ampersand. Next, person dot year. So percentage D. So these string, int, okay, and float. So person dot year is an integer, and next person dot salary is float. So we took input for all the 5 values. Okay, say we enter the name of the person, date, say 3, okay, month February, year some 2000, okay, and salary some 50,000. So it will take input. Next we have to print it. So to print the variable also we'll use similarly. Note, this is a typing error. Okay, there is no ampersand in printf, right? I'm sorry for this. Okay, so here while printing there is no ampersand. I just copy paste. So here we are going to print each, otherwise it prints the address, right? So we should not give ampersand in printf. So here we are printing each of the name variable member values. So whatever input we took, so that is taken for person, we print his name and print the day 1, 2, 3, whatever input we have given. So 3, and month is February, we gave, right? Year 2000, salary 50, right? So all the dates, all the inputs we have given, we print it. So this is how each structure variable can be accessed, right? So person is a structure variable and these are the structure members. So to access each of them, we will use a dot operator. Person dot name to you access the name, person dot day to access which date he was born, person dot month for the month he was born, person dot year for the year the person was born, person dot salary for the salary of that particular person. Now we may declare comma person one, then that person one becomes the second person. He may have a different name, different date of birth, different salary, right? So similarly we can declare structure person one, person two, and n number of persons. Then similarly we will give for person one dot name, person one dot date, person one dot month, person one dot year, person one dot salary. So this is how we can access the members of the structure. Is this clear? How to access member of a structure? Using the dot operator, we access
Yes, ma'am.
members of the structure. Okay? Yes. Right. So here, yeah, that's true. It's a typing error. Okay. So here instead of double quotes, it became bracket. Yeah. Clear? So is the syntax clear for accessing the structure members? Person dot name, person dot day, person dot month, person dot year, person dot salary. Person is name of the structure variable. All these are members of the structure. To access members of the structure, we will use a dot operator. Okay, so this is how we can take input. So as I see, so every time for a new topic, we will take input and print, right, output. So be it array, one dimensional, two dimensional, string, or many concepts we saw. So similarly, we have this. You can execute this program also. If you want to declare, you can declare comma person one. Okay. Similarly, you take input for another person, that second person's name, his or her date of birth and salary, and print it. Okay. So this is how we can take input. So here we have defined the structure. Okay. Then here we have declared a structure variable. Okay. So then we have taken input for the structure member elements. Okay. Then we have printed the values of the structure members. Is this clear? Yes. Okay. So we'll continue. So now how to initialize this? So here we have taken different variables, okay, different members. Now we cannot simply initialize individual members. We cannot write name equal to Sneha. Then how does it take, right? So like we declare for any variable, we cannot write date equal to 3. So that means every person was born on the third month, third date, right? So that is not possible. So we cannot initialize here like we do for variable. So there is some rule. We can take input like this, or if we want to initialize, we want to give the value. How do we do that, right? We cannot write here int month equal to January. So that means every person was born in January. So that is not possible, right? So we may have people born in different months. So we cannot write initialization along with the declaration of the member here. How do we initialize then? So one way is by taking input like this, we just saw. Another is, say, we can give the order. So in this case, we can give the values. So first one should be name itself. So we cannot say February, or we cannot declare like 3. 3 is not a name of a person. Okay. Then here we cannot give January. January is not the day. It is an integer, right? We have to give numbers. So the order has to be taken care. So while initializing, so in the same order, we have to initialize. So whatever order we give for the members. So if we have given like this, then while initializing also, same order we have to follow: name, date, month, year, and salary. So that is the first thing. So we can initialize partially also. So similar to any string like we have seen. So all other members which are not initialized becomes 0. And if it is a string or a character, it becomes null. So later on, we can change those values, right? If you want, you can give all the 5, right? All the 5 we can give. So or else we can initialize 1 or 2. The others will be null or 0. If it is integer and float, it will be initialized to 0. If we don't, if we have partial initialization, if we initialize, give only name and day, then for character or string, it becomes null. Let us see how to do this, right? So that is a rule, first thing. Okay, so we can initialize all at once, or we can have partial initialization. Let us see here. So we have one more example wherein we have declared. See, you observe here, after struct there is nothing mentioned. That means, is the name of structure missing? Yes, while defining there is no structure name. We can do like this also. There is one flexibility in the syntax. But what happens, we should not close the semicolon here. If we have given like this, it is, say, the weight and height of students. Okay, so here we see different type of initializing a structure. I'm sorry, example 1. We'll go back. Yeah. So here we have a structure. We can give the name of the structure later also. So in this case, equal to 60, 180.75. Weight of the student is 60. Height is 180.75. Similarly, we can give some more students also. So here, this structure can be initialized later by taking input, or in the program itself, we can give values like this. So let us see some more examples. Okay, so here we have given all. You can see that the order should be followed. First one is integer, second is float. So first is integer, second is float. Okay, So here we have one example. Another, say if we want to give the student details. So there are many students. So we want to store the weight and height of each student. Here we have given the name also, right? Struct ST record, student record, for example, ST underscore record is the name of the structure. So here we have just defined it, completed. So semicolon indicates definition of the structure is completed. Now we want to initialize. So to initialize, we have to follow a format. So struct is a keyword, space, st record is name of the structure, followed by student1. Student1 is a structure variable. Okay, so like we saw book 1, book 2, book 3, previous example. Similarly, we have student 1, any number of students we may give. So student 1, we are initializing 60, 180.75. That means this weight of the first student is 60, height is 180.75. Then student 2, this is small s, okay, that is typo. So student 2, weight is 53, student 2 height is 170.60. Like this, we may declare any number of students. So here we have two variables. So in this case, we have initialized the value. So we can, here we have declared completely and initialized completely, okay, both the details. So we may give just 60. In that case, height will be initialized as 0. If there was a character and if we have not initialized, then character will be initialized by default as null. Okay, so the order has to be followed. Here it is int float, while initializing also it should be int float. Okay, first variable is int, second is float. Okay, so this is another example. We see different ways we can initialize. So this is example 2. Okay, so here we have one doubt. Okay, so about dot operator. Okay, let me go back to that. Right, so here we have seen an example. So here we have declared a structure name is personal and the name of the variable is person. Okay, note that you should not write personal dot name. Personal is the name of the structure. Okay, so person is the name of structure variable. So this is what is a name of the variable. So name of the variable dot member. That is how we can access each member. Person dot name. Then person dot day is day that particular person was born, first, second, third. Okay. Then month, person dot month we can use to access the month. So this person was born in January, for example. So that is a character or a string. So we have declared char month of 10. So which month was this person born? Person dot month will give us the month in which that person was born. It is not same as calling a function. No, it is accessing the member. Okay, so do not get confused with the function. Here we are not calling, right? So that is the second doubt. I hope the dot operator is clear. First of all, how to access the member. So here we have variable name dot member name we can use to access the member. So if we want to see what is the name of the person, we want to print it. So we will simply give, okay, it is a string. So percentage s and person dot name. We want to print what is the date in which he was born. Say 5th he was born. Okay, so that is an integer. We give percentage d and we give person dot day. So this dot means this is a structure variable dot and day is a member of the structure. Okay, so structure variable dot member of the structure. So day and person dot month means month in which this person was born. Similarly, we have person dot year, person dot salary. Dot operator is used to access the members. I hope this is clear. Okay, yes, so we will continue. So here, first thing for your lab sheet, it has two problems, one structure based, one more is union based. Before going to that, so structure is program 8. So it says write a C program with a structure name called student with the member names as string name, okay, ID number is a string, okay, so name of the student is a string, ID number is also a string, and marks in 3 subjects. Okay, all are integers. M1, M2, M3. Say first subject marks, second subject marks, third subject marks. And then we have one more is average. which is a floating point variable. We want to find the average of the marks. So the question says, declare the structure variable, read the student details, all these student for all these details for each student we have to read, and then calculate average and display the same. We have done this using main, right? So we have taken input for marks of a student and then found average of the marks. Similarly, now we will do the same program using structure, right? So let me see this. So here we have the program in the lab sheet as well, but I will open the notepad. Okay, so this is program 8. So here we have the program. So we are declaring a structure. So in this question, it says that it is regarding finding the average marks of a student. So we have some details of a student. So we will declare, okay, stdio.h, and then struct is a keyword, space, student is a name of the structure. And we have some members. What are they? Name, it is a string, character array, ID number, again a string, character array. We are declaring 3 integers, marks 1, marks 2, marks 3, marks in 3 subjects, and then average is a floating point. Note the semicolon, it indicates that we have completed defining the structure. So this structure has 1, 2, 3, 4, 5, 6 members. If we declare it at once also, they are all different members. Okay, so 6 members in this structure. So semicolon indicates we have completed defining the structure. Now we have to use that variable. So first we have to declare. So like we declare variable int a. So similarly we have to give the data type. Here this is of data type struct student. So that is the keyword struct space the name of the structure. So struct student. Say we want to give s1 as the name of the first variable. S1 is a structure variable. Now this S1 is for student 1. So we want the details of first student. So S1, how do we access the name? S1 is a variable, structure variable. How can we access the name? Name is a member. Anyone? S1 we have as a name of the structure, okay, variable. And then member is name. How do we access this structure member? Using dot operator.
Dot name.
Yes, one dot name. Very good. So first thing is we have to take input for all the details of the student. Okay, name, ID, and 3 marks, and then calculate average. That is the problem at hand. So we will take input one by one. First we ask enter the name of the student. Now we come to main. Okay, so note here also control starts from main. When we say structure student, it will go back and see what are the definition of structure and come back to main. Okay, so it has defined one S1 student. So this student has a name, ID number, 3 marks and average. That is defined. Now we have to take input. First thing is take input for name. So enter the name of the student. We give a message and then take input. Since it is a string, we can use get s function. Get s. And how to access this member? S1 is the name of the structure variable. Dot name of the member is name. Okay. Name we give. So this will take input for the name of the student. Next, we have to take input for ID number. So structure S1 dot ID number. So this is to take input for ID number. Since it is alphanumeric, we will declare as string only, character array. Otherwise, it cannot take letters, right? 20191 and ISE 010, something like that. So you have both alphanumeric variables. So we will declare a string. So we have declared a string. We take input for ID number. Next, we need to take input for the marks in 3 subjects. So marks in the 3 subjects is taken. So all are integers. So first one we have percentage %d and s1.m1. Next, and s1.m2 and s1.m3. So we take input for the 3 integers. Note the format specifier should be given correctly. Okay, so we took input here. Okay, name, ID number and marks. Next we have to find average. So average we cannot simply write AVG. So it is average of that particular student, right? So I cannot write average of Andrew and give it to Harshita, right? So like that, it cannot be done. So average of one person has to be given to that same person. So here S1 has to be specified. S1, student 1 average. So we have to calculate. So in that case, give S1 dot average. That means this is the average of student 1. So as of now, we don't know name. We are identifying that particular student as student 1. Okay. So student 1 average is nothing but student 1 dot marks 1 plus student 1 dot marks 2 plus student 1 dot marks 3. How to find average? Add all of them and divide by 3. Okay. 3.0 because of typecasting. We don't want the floating decimal part to be truncated. So we will take the entire thing. If it is 16.5, we have to give 16.5 and not 16. So that is why we will use 3.0. Okay. So we calculated average. So marks 1 plus marks 2 plus marks 3 divided by 3 will give us the average, which we have stored in S1 dot average. Then next is simple. We took input, calculated, print each one, right? Print the name, then we print the ID number, and we print the average. If you want, you can print M1, M2, M3 also. Okay. So let's execute this. I hope the program is clear. We took input for a one particular student, the student's name, ID, and marks in 3 subjects. And next we are calculating average of those 3 marks, and then we are printing it. Okay. So let us see how does this work. So here, I hope this is visible. Okay. So we have the command prompt. So compiling GCC. Okay. Yeah. We got the prompt. Give a name of the student. Say we give some name. Okay. Now ID number. I give some ID number. Okay. If you want to give in that syntax 1 CSE 000, right? Some random numbers and then marks. Right, 3 marks in 3 subjects. So it displays. Now you can see it has taken input. Okay, name is Raj and ID number. So is this one which is given as input, and then we gave marks in 3 subjects. So we calculated the average. Okay, and then print the name. Name is Raj, ID number is printed, and average which is calculated is printed. So this is the first program in structure. Similarly, you can execute the programs we just discussed, like person details, person name, date of birth, and salary. Take input and print it. This can be utilized. So we saw taking input and calculating something. Similarly, for any application, we can define a structure, okay, which is for our application. However we want, we can declare it, and then we can take input, do some computation, and display. So that is the first thing regarding structures. Is this clear? Did you all understand structures? Yes or no?
Yes, ma'am.
Yes. Okay. Right. So here we have one more thing is union. So here basically we are introducing the topics. Okay. So going back to the PPT. Right. So this structure which we just discussed. Now what is this union? Union is also like structure itself. Okay. But there is only slight difference. So it is also modular programming. So if we are defining a union, the syntax is exactly same. Okay. But the keyword in struct, it is union. Note this keyword. Sorry. Keyword is union and name of the union is item, right? And this is also heterogeneous collection. Now you may ask me, if it is working same, why do we need both, right? So here there is a slight difference in terms of memory used. We will come to that in the next slide. So if you see, the syntax is the same. We have the keyword union space name of the union, okay, and the members can be of different data type. If we see here, we have int m, float x, char c, all different data types. These are all members of the union. So how does it differ from structure? So when we say this, in structure, each of the member has a separate memory location. Now you observe this. So if we had the same thing stored as a structure, okay, so int m, float x, char c. So how many bytes for integer? So it may be 2 or 4 bytes depending on the compiler. Let us assume it is 4 bytes. Okay, nowadays usually 4 bytes. So 4 bytes for integer, 4 bytes for float, 1 byte for character. So totally we have, for a structure, 4 plus 4 plus 1, it needs how many? 9 bytes if this was a structure. Now, because this is a union, so it will store only the maximum variable memory. What is maximum? Out of 4, 4 and 1, maximum is 4. So it will store a maximum of 4 bytes only. If this was a structure, total memory occupied would be int 4 plus float 4 plus char 1, 4 plus 4 plus 1. If this was a structure, if we had declared here as struct item, so then it would be 9 bytes. But in union, it is going to occupy only 4 bytes. So the memory of the largest data member is taken only. So in that case, how will it store the data? That is what we have in the next slide. So in this structure, each one will be stored separately. So if we have a structure, is this white screen visible? Yes. Okay. So let me see. So here we have one structure. So I will draw this. So in this case, we have 3 variables, right? 4 bytes. So just correspondingly 4 bytes and 4 bytes. So we had one int. What was that variable? M, X and C. Okay. So here we have M is an integer. Okay. So in this case, we have one M. We have the structure, it will store M integer here. Okay. And then X is a float, it will store here. And C is a character, it will store here. So it will store like this. So here we have how many? 4 bytes for integer and 4 bytes for float and 1 byte for character. So here totally it takes 9 bytes for structure. So this is a structure. If it was a structure, it would have taken 9 bytes. Okay. Now instead, if this was a union, like how we have defined, so going back to the PPT, so if we say this is a union, right, this is a union, it will take only 4 bytes. How will it store? Instead of storing one next to the other, so if it was a structure, first 4 bytes integer, next 4 bytes float, next 4 bytes character, it would have stored. Okay, one by one, each of them is stored. But the difference between structure and union is it is stored with the maximum variable memory. So in this case, maximum we have is for float. So float considering that, or int. So if we have taken 4 bytes, so storage of 4 bytes is taken, you can see. So it will store M or X like this and then C in the same location. Now, how can you handle this? If all are stored at the same place, how can you access them? So how do we print it? That becomes an issue. So that means union works in a peculiar way. It works in a different way. So we can access only one member at a time. There may be applications in which we are not accessing all members at all. We may have defined them so that some or the other point we may require. So we are accessing only one element at a time. In that case, we can use union. So it will store the same place is used for storing integer, same will store float, or same place will store character. So any one at a time only we can access. So if we try to print all of them, it will print only one value. Okay, so that is what we have. If we have declared like this, int item and code is the variable of, okay, of type union. Code dot m will access the first element, code dot x to access second element, code dot c will access the third element. So at a time we can store only one element. So that is the way a union works. So to access, we have code.m, code.x, or code.c. So we can access only one variable at a time. So either we use integer or float or character. Only one of them can be stored and accessed at a time. Whereas in structure, we can store all the three variables and access all the three variables. That is the main difference. One difference is with respect to memory used. So if we want to have application where we want to save some memory and we know that only one variable is required at a particular time, then we can go for union. Okay. So in this case, we have declared x comma y. Another example, union test x comma y is a member. So we have T1 here. So to access, we can give T1.x, T1.y. So we have declared this union variable T1. So initializing T1.x is 2. So if we try to print, so after making x is equal to 2, it will print x equal to 2, but y it will print some random value or 0. You can execute this same program as well. Just include one stdio.h, hash include stdio.h. Okay, so when you try to print both the elements, it will print only x. It will not print y. That is how union works. Now, if in case instead of x, we initialize y, t1.y equal to 10. So in that case, it will print y. It will not print any value here for x. Even though it was initialized, it will not be accessible. We have initialized x equal to 2, but still it will not print because these members are of part of the union. So either we can access x or we can access y. We cannot access both at the same time. So instead of storing 4 plus 4, that is 8 bytes of memory, this will occupy only 4 bytes. So we are managing with only 50% of memory. So we are saving a lot of memory by using union. So that is provided we have application of this sort, wherein we are going to access only one member. Okay, only then we can use union. Okay, so let's go to the lab sheet. So we have one as program. So what is this program? 9. Right. So program to illustrate structure and union. We are taking the same example here. Okay, for the string. So name, age, and marks. So here we are taking only 1 marks for a student. Union also we are taking same as structure. So if we say this structure, 24 bytes for character, 4 bytes for int, age, 4 bytes for marks. 24 plus 4 plus 4, it will take 32 bytes. So that is how structure is stored. So 24 plus 4 plus 4, it takes 32 bytes. But when we come to union, it takes the maximum member, that is 24. So it will not store this separately. So it will take maximum of 24 bytes only. Okay, we have declared one structure and a union, both of the same type of student. This is student, student 1. Both have the same members. To see the difference between union and structure. So to access the union member, it is the same dot operator. Okay, so we are declaring one U1 as member of union. S1 is member of the structure. Just I will display the same. So here we have problem 9. I think this is clear better. Yeah. So we have defined a structure student with name, age, and marks, and union student with name, age, and marks. Okay. So in this case, we are taking input first. Directly, you can see here, structure student S1. S1 is a variable of type struct, and we have initialized name, age, marks. Next, for union, we can give only one value at a time. U1 is a variable of type union. We have given only one value, name. Okay, so we can give only one value. It can be either name or age or marks, any one of them. So we have given the name here. Next, we want to print the structure's size. So we see that 24 plus 4 plus 4. So this is 32 bytes. Size of, we have used size of operator. Size of S1 will print the size of the structure variable. Similarly, we are printing the size of union. So if it is taking the size of the maximum variable, that means it will take only 24. That is 24 bytes instead of 32. Okay, next we are printing the values, structure variable. So we print s1 dot name, which we took, that is Mehul. S1 dot age is 20. S1 dot marks will be 95.5. Next, For union, we can give only one at a time. So we have given name already. So we can print that name. Okay, u1 dot name. In case we give age, we initialize age equal to 20, we cannot print the name. So you can see here, we can print only age, irrespective of whether we have initialized the other variable or not. For union, we can access only one variable at a time. Next, we have marks. We have initialized 98.5. Now you may say that name is there, Mohak, marks, age is there 20, marks is there 98.5. All three variables are available, but it will not print all of them. It will print only one of them. So here we are trying to access the marks. We can print only the marks. We cannot print the age here along with marks. So that is the concept of union. Okay, we can access only one member at a time. Let's execute this. So then we can see, right? So here you can see size of the structure is 32, 24 plus 4 plus 4. Then structure union, size of union is only 24. Size of the maximum union variable, that is char name. Then we printed the variable details. So this is a heading we printed. You can see all the three variable values are printed. But for union, we gave only name. And next we initialized age. So we printed age. After that, we initialized marks and we printed marks. We cannot initialize all at once and print them for union. So this is for structure and this is for union. I hope this is clear, right? So the same thing you have in the lab sheet as well. So this completes the module. Is this clear? So please execute this. Rachana has raised hand. Any doubts, Rachana? Tell me. Did you understand this concept? Yeah, Harshraj also. Let me know if you have any doubts. No? Okay, by mistake.
Ma'am, union part you tell again.
In union, only one
That
variable,
last part
one
of the
member,
program.
only one member can be accessed at a time. Okay? That is a difference between structure and union. In structure, all the three members can be accessed at a time. So like you can see here, S1 dot name, S1 dot age, S1 dot marks. Like this, we cannot do for union. Okay, we cannot print all the members at a time. We can print only one at a time. So we have initialized Mohak, then we can print name. Okay, now if we initialize age, we cannot print name because it will take that memory is replaced by integer age. Okay, so only one member at a time we can print. If we want to print marks, then we have to initialize that separately and print. So union can be used whenever we have an application where we want to access only one member at a time. So this advantage of this union is it saves a lot of memory. If we have such applications, so instead of 32 bytes, we are using only 24 bytes. You may imagine the same in terms of thousands, right? Instead of 3000 bytes, if we are using 2000 bytes, then it saves a lot of memory, right? So this is a smaller example which we see. So size of structure will be total 24 plus 4 plus 4. So that is why it became 32. But size of union is the size of the largest element. So this is 24 bytes. Okay, character 24 means 24 characters, right? 24 into 1. So character of name of 24 is nothing but 24 bytes. This is 4 bytes and float is 4 bytes. So among the three values 24, 4 and 4, the largest is 24. So the size of this union is only 24 bytes. Whereas similarly, same thing we have defined in structure. If you observe, it is exactly the same, but it is structure. So it will take the total 24 plus 4 plus 4. So it takes 32 bytes of memory. Okay, so that is the difference between structure and union. I hope your doubt is clear now.
Yes, ma'am.
Yes. Okay. Please execute each of this program. Anywhere you get any doubt, you can ask. Right. So you can send messages also. Right.
Ma'am, we'll access one by one, no, ma'am. So in the same memory it will be accessed, ma'am. Like first name, then
Yes.
age it will come.
Same memory is used for all the three. Okay.
The first access will go, no, ma'am, when we access the second part.
Yes, correct. Only one member we can access at a time.
Okay. ma'am.
Okay. Yeah. Any other doubt? Okay. So we'll end for the day. Thank you. Thank you very much.